Jadhav Civil Academy. In this class, I am going to discuss about type of supports in beam. Before going to the actual topic, that is type of supports in beam, let me discuss a small point, that is when a beam subjected to any external force, it experiences two types of motions. Those are, one is a translatory motion and another is a rotatory motion. What are those? Translatory motion, another is a rotatory motion. So what do you mean by this translatory motion and what do you mean by this rotatory motion? Let's say, take an example of beam here, right? It is not supported with any support. If you apply any horizontal force in this direction, say the force is F, right? So because of this horizontal portion, the position of beam, suppose initially it is at a position of A. After application of force F, it will shift another position, say to B, due to this external force F, right? So it is moving in horizontal direction. So we can call shifting the position of one place to the another place. Then we can call it as a translatory motion. Similarly, over the same beam, if you apply a vertical force like this, then initial position of beam is A here. Because of application of this vertical force on the beam, it will shift it to this point. This point, that is point B, right? This point B. So these are called a translatory motion in the beam. Similarly, what about the rotatory motion? If you apply a movement, it may be a clockwise movement or a anti-clockwise movement on a beam about a fixed point, say this is a point A. If you apply the movement, say it is a clockwise movement, then this beam also rotate about this point, like this, and like this, right? This is called a rotatory motion. With the knowledge of definitions of a rotatory motion and a translatory motion, let me define what is the definition of support is. What is the definition of a support is? The support is defined as which resists the movement, in the beams due to externally applied loads, right? The definition of support is which resists the movement in the beams due to externally applied loads. So these movements are maybe a translatory movements, or I can say a rotatory movement. To resist those movements in the beam, we use supports in the beam. So let me classify the types of beams, types of supports. So these are basically four types. One is a simply support, or you can say free support, and second one is a roller support, and third one is hinged support, and finally fourth one is fixed support. So let me explain first what is the simply support is. So simple support nothing but the beam which can rest freely over the support. That support is called a simple support. Simple support. So the symbol for this simple support is, say it is a simple support. Here it is a pillar or column, what we can say, and over this our beam is simply resting. Over this beam, over this support, our beam is simply resting. So this support is called a simply support, we can say, right? So now we need to find out what are the number of reaction for these simple supports. Now we calculate number of support reaction for simple support. So what do you mean by this support reaction? So while calculating the support reaction, what we'll do, we will remove this actual support. In place of this support, we will introduce a reaction. So for that simply supported beam, the number of reactions are simply supported support. The number of reactions are only 1, right? Here, the number of reaction can be calculated. The number of reaction in any support is equal to number of restricting moments. Number of restricting moments. So that means, as we have 3 moments, one is a translatory motion in horizontal direction, and a translatory motion in vertical direction, and a rotation, that is rotating moment. So among these 3 moments, by using up this simply support, how many moments are restricted? So the number of reaction is equal to those many number of moments are restricted. In this way, we can calculate the number of reaction in a particular support. So let me apply in this arrangement. This is a support, simple support. Over the simple support, we have a beam. If I apply a horizontal force, as it is a freely supporting or freely resting over the support, if you apply a horizontal force here, this beam will move from here to here. So there is no restriction of movement in horizontal direction, right? And if you apply a movement, it is a clockwise movement or an anti-clockwise movement, it will rotate about this point. So it can freely rotate along this point. So we cannot restrict the movement of this beam when it is supported over a simply support. So there is no restriction for movement or a rotation, right? And if you apply a vertical force here, this vertical force will be balanced by the reaction force. So we can arrest the moment of this beam in vertical direction. So we can say there is no movement in vertical direction. So we have a restriction of a movement in vertical direction. So among these 3, how many numbers of restricted moments we have? That is, there are 2 non-restricted moments and 1 restricted moment. So what are those 2 restricted moments? That is a horizontal movement we cannot restrict, and rotation we cannot restrict. Because of the simply supported support, we can restrict this vertical movement of a beam. So number of reactions in this simply support is equal to number of restricting moments. So the number of restricting moments are 1. So we can say there is one number of support reaction in simply support. So this simply support can be shown. Say this is a point A and this is a point B in the beam, and this simply support has to be shown in this line with arrow in vertical direction, and as it is a reaction that is represented with a R, and this reaction is acting at a point A, so we can write it as a RA. And this reaction support should act normal to the axis of the beam. So assume that this is the axis of the beam, and it will act normal to the axis of this beam. So this, the angle between this normal reaction and the axis of beam is 90 degrees. Next we will discuss about a roller support. What is the definition of this roller support? If beam end is supported over a roller, that means that is a roller support. If the beam end is supported over a roller, that is called a roller support. So what is the symbol for this? So this is a beam and this is the one of the end of the beam. If this end of the beam is supporting over a roller, then we can call it as a roller support. This is the symbol for roller support. That is a triangle. Below the triangle we have some rollers, and below that we have this symbol, that is natural ground, on ground, which is resting on that support. Right. So this is support A. So if you observe the number of reactions in this roller support, again the number of support reaction in any support that can be calculated based on the three motions. What are those? The translatory motion in horizontal direction, translatory motion in vertical direction, and a rotation about a point. Based on these three motions, we can decide how many number of support reactions are there. So let me check here on the roller support. So it is a roller support. If I apply a horizontal force on this, right, it will roll in horizontal direction. So there is no restriction of movement in horizontal direction. Okay, and if I apply any movement here, so it will roll about this movement, about this. If it is a point, it will we have a rotatory motion about this point for this beam, right? And if you have a vertical force, this vertical force is restricted by reaction of this support. So that means we have a restriction in vertical direction, right? So we are not having restriction in horizontal direction. We are not having restriction in this movement, that is a rotatory movement, and we are having a restriction in a vertical movement or vertical translatory movement. So the number of reaction is equal to number of restricting movements, right? So the number of restriction movements are how many here? So for the roller support, we can calculate the number of reactions. Those are equal to number of restriction movement. Here in this case, we are not having restriction of movement in horizontal direction, right? We are not having restriction of movement in rotation, but we have a restriction in vertical direction. So the number of support reaction for roller support is 1. How many support reactions we have? There are 1 support reaction for roller support. So if it is a beam, for analysis, that support is acting at A. By removing this support, we will give a reaction R here. We will give a reaction R here. As this reaction is acting at a point A, we can designate as R suffix A. Again, this reaction is acting normal to the axis of the beam. That means the angle between this normal reaction and the axis of the beam is 90 degrees. Now we will discuss about hinged support. Let me write what is the definition of hinged support is. If a beam end is supported by hinge at its end, that is called a hinged support. So the best example of hinged support is, I will show you practically. Here I have a laptop, right? If you see the laptop, so here 2 supports are there for this plate and this vertical plate, and this vertical plate is mounted over a support called hinged support. So these are the 2 hinges. So you can take one more example of your door. If you open or close the door opens, a closing of door and opening of door is depend upon the hinged support. That is the best example I can say for the hinged support. So how we can designate, or how can we symbolize as practically? So the symbol for this hinged support is, so this is a beam, right? And we have a triangle. Below the triangle we have these lines. This is called a representation or a symbol of hinged support. It is what? A hinged support. So this is a hinge. Now we need to calculate what are the number of reactions for this hinged support. Number of reaction for hinged support. What is the definition of number of reaction? The number of reaction is equal number of restricting moment. Number of restricting moments. Right. So let me explain how many number of restriction moments we have in this and how many number of non-restricting moments we have in this. Right. As it is a hinge, if you apply a horizontal force, due to this support, it will not move. It will not move in horizontal direction. So we have a restriction in horizontal direction. Right. And if you apply a vertical force here on the beam, because of this support, we don't have any vertical motion or vertical movement of this beam due to this support. So we can say we are restricting the vertical movement also. Right? And if we apply any movement here, it will move clockwise or anti-clockwise direction. So we have a free movement. We can say it is a free movement. So there is no restriction. There is no restriction of a movement in the rotation. So from this I can say we have restriction in two movements and non-restriction in one movement. The restriction in two movements are, that is horizontal translatory motion and vertical translatory motion, and there is no restriction of rotatory motion. So we can say we have the two number of restriction. So we can say the number of reactions equal to 2. The number of the number of reactions for hinged support are 2. So how they are look like by the analysis? Say this is the line of action of beam or the line of center line of a beam, and one reaction is acting in vertical direction and another reaction we have in horizontal direction. Suppose they are acting at a point A. Then we can write this is RAV, this is RAH. What do you mean by this? R means reaction at A in vertical direction, and what do you mean by this? Reaction at A in horizontal direction, and the angle between these two must be 90 degrees, and these two are mutually perpendicular to one another. The last type of support is a fixed support. So when it is defined as when the beam ends are fixed, then the support which is supporting at the end of the beam is called a fixed support. Generally we can symbolize, or we can the symbol for this fixed support is like this. So this is the symbol for fixed support. What is this? It is a fixed support. Right. So this is a beam, you can say, and this beam is inserted into the wall. This is a beam, right? It is a beam, and this is a wall, and this beam is inserted into the wall. Then it will become a fixed. So the support is called a fixed support. So let me calculate how many number of support reaction we have for this fixed support. How to calculate that? Again I will write the formula. The number of support reactions is equal to number of restricting moments. Right. So let me see. Let me explain how many number of restricted moments are there in this fixed support. The name itself indicating that it is fixed. So we don't have movement in any direction. We don't have a movement in horizontal direction. We don't have movement in vertical direction, and we don't have a rotation. Right. So you see, if you apply a force F in horizontal direction, because of this fixity, this will not move in horizontal direction. So we have a restriction of movement in horizontal direction. So there is no horizontal translatory motion. And if you apply a vertical force here, because of this fixity, it will not move in vertical direction. Here also we have a restriction in translatory motion of the beam in vertical direction. And finally, if you apply any movement here, Because of fixity here, the fixity between beam and the supporting wall, so we will not have any movement. It may be we don't have any clockwise movements or we don't have any anti-clockwise movements. So the rotatory motion also is restricted. So how many restricted movements are there? Here horizontal translatory motion is restricted, that is 1, and vertical translatory motion also restricted, that is 2, and the rotatory motion also restricted, that is 3. So the total number of support reaction in fixed support is 0,3, that is 3. The how to, for analysis purpose, how to indicate these 3 support reactions? So here we have a point A. At this point A, we have a restriction in vertical direction. So we have RAV, and we have one more reaction in horizontal direction, that is RAH. Along with these two, we have one movement restriction, that is MA, that is movement at point A. So here I am writing the direction of forces vertical, horizontal in this direction and anti-clockwise direction. In nature, that may be a reversing direction also. But for this example, I am assuming in this direction, vertically upward, horizontally right side, and anti-clockwise movement. So this is one reaction, this is second reaction, and this is a third reaction. It's a moment reaction. So the number of support reaction in fixed support is 3. So finally, in today's class, we have discussed about type of supports and number of support reactions. The type of supports are simple support, and for the simple support we have a number of reaction is 1. For roller support we have a number of reaction 1. For hinged support number of reactions are 2, and finally for the fixed support the number of reactions are 3. Thank you.